Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic vectors. In the previous video, we learned how to find the magnitude of a column vector. In this video, we are going to learn how to find the direction of a column vector. So to find the direction of a column vector, the first thing you need to do is to represent the vector on a diagram. We've learned how to represent column vectors on a diagram, so we are going to apply that here. After that, the direction of the vector is the total angle the vector makes with the geographic north by measuring in the clockwise direction. We know this from our studies on bearings, that bearings are taken from the geographic north in the clockwise direction. So the direction of the vector will be the total angle the vector makes with the geographic north when you measure clockwise. We are going to find out how to do that. Then we use the appropriate trigonometry ratios to find the required angles. So let's pick some questions and see how to do this. Find the magnitude and direction of the following vectors. Leave your answer in one decimal place. So you have been given 4 vectors and we are being told to find the magnitude and direction of each one of them. You will solve the first one in this video, then we will consider the others in the subsequent videos. So the first one is find the magnitude and direction of vector AB. And vector AB has the components 1, 3. In the previous video, we learned how to find the magnitude of a vector. So magnitude of vector AB will give us square root of the x component squared, so 1 squared, plus the y component squared, so 3 squared. And this will give us square root of 1 squared is 1, 3 squared is 9. So we are going to have square root of 10. When you find square root of 10, you are going to get 3.2. Remember, we are leaving our answer in one decimal place, so 3.2. The units was not given to us, so 3.2 units. Let's move on to our main study for this video, finding the direction of vector AB. Don't forget that vector AB has the components 1, 3. The first thing we need to do when you want to find the direction of a vector is to draw the vector on a diagram. So in our studies on drawing vectors on a diagram, we said that when the x component is positive, you move towards the right, and when the y component is positive, you move upwards. So here what it means is that if A is our starting point, as we can see here, we move 1 towards the right since it's positive. Then we will move 3 upwards since the y component is also positive. So if you draw a line from 1 and another one from 3, they are going to meet at this point, and that point is called point B. So you see that this vector here, AB, now look at the direction of the arrow. So AB, so moving from A to B. Okay, now how do we find the direction of this vector here? We know from bearings that we take our bearings from the geographic north in the clockwise direction. On this diagram here, this is our geographic north. So we are going to take the bearing from this geographic north onto the line or onto the vector AB. So the line joining A to B. So it means that this is our direction, the angle here. If you call this angle theta, it means that this angle theta here is our direction. So what we have to do now is to find the value of theta. So remember that you always measure the bearing from the geographic north in the clockwise direction, and you are going to measure it from the geographic north up onto the bearing, up onto the vector, or you are going to measure it from the geographic north onto the line joining the vector or the 2 points, so the line joining A to B. So here if we take that, if you measure it from the geographic north onto the vector, we are going to get this angle here. So our job is to find the value of this angle, and that is exactly what we are going to do. Okay, so to find the value of this angle, I'm going to call this angle here angle theta. I'm calling this angle here angle theta. Now, you can see that this forms a right angle triangle. Point A, point B, and the point here forms a right angle triangle with the 90 degrees at this side. We know that from this point here to this point is 1. You see, from A to this place is 1. So from here to this place is also 1. From A up to this point here is 3. So that point is also 3. So we have theta here. We have the opposite to theta to be 1. We have the opposite to theta as 1. We have the adjacent to theta as 3. And we want to find theta. So we are going to use tan because we have opposite, we have adjacent. So we can say that from this diagram, the direction of the vector AB is theta. Okay, now we can find theta from this right angle triangle here. If we use tan theta, we know that tan theta is equal to opposite, which is 1, divided by adjacent, which is 3. So 1 is opposite to theta, 3 is adjacent to theta. So tan theta is equal to opposite over adjacent, which is 1 over 3. Theta will give us tan inverse of 1 over 3. We know how to find tan inverse, right? So you switch on your calculator, you press shift tan 1 over 3. 1 over 3, then you close the bracket. You are going to have 18.434. The number goes on, but the question told us to leave our answer in 1 decimal place, so we are going to have 18.4 degrees. So we can say that the direction of the vector AB is 18.4 degrees. So this column vector here, we have been able to find its magnitude as 3.2 units, and we have been able to find its direction as 18.4 degrees. So you see that this column vector, we have written it in the magnitude bearing form. So the magnitude is 3.2 units and the bearing is 18.4 degrees. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to take another question on finding the bearing and magnitude of a column vector. Bye bye.